You know, our phones, our laptops, we use these things all the time, right? It's like they're practically a part of us. But have you ever stopped to think, what is a computer really? Like at its absolute core. Let's forget all the apps, the fancy screens, all of that for just a minute. We're going to peel back all those layers and get to the surprisingly simple idea right at the heart of it all. Okay, so let's dive in. It all starts with a super simple idea. Because really, when you get right down to it, a computer is just a smart and really fast machine. Yeah, that's the core of it. A computer basically does just two things. It takes some kind of work from us, and then it gives us back a result. And it does it incredibly fast. That's it. To see exactly what I mean, let's look at a perfect example that we all know. So, to make this totally crystal clear, just think about one of the most basic computer programs out there, the calculator on your phone. It's a perfect, simple example of a computer in action. Okay, so you open up that calculator app, right? And you type in 2 plus 2. That simple action, that's the task. That's the work you're giving to the computer. You're basically handing it a problem to solve. And boom, almost instantly, you get the answer, 4. But, and this is the really important part, the computer isn't thinking. It has no idea what 2 is or what plus even means. Nope, it's just a machine following a pre-written recipe, following it to the letter. And that one simple action, it actually shows us the fundamental process behind everything a computer does. So that super simple calculation, it actually reveals the 3 magic steps that every single computer follows. I don't care if it's your phone or a massive supercomputer, they all do this. It's always these 3 simple steps. Step 1 is input. That's us typing in 2 plus 2. Step 2 is the process. That's the computer doing the math, working on the problem. And finally, step 3 is the output, the number 4 popping up on your screen. Input, process, output. Every single time. It's that simple. Okay, but this whole thing, as smart and as fast as it is, well, it all depends on one really big secret.
And that secret is, a computer can't do anything by itself. Not a single thing. Think of it like this. It's a world-class chef in the most amazing, state-of-the-art kitchen you've ever seen, but they have 0 recipes. All that power, all that potential, is completely useless until someone tells it exactly what to do, step by step.
And right there, that's the huge difference between a human brain and a computer. We can think, we create things, we make decisions, we can improvise. A computer? It just follows the rules. It executes our instructions with incredible speed and perfect precision, but it can't, for the life of it, come up with those instructions in the first place. So this act of giving a computer its instructions, writing out all those rules for it to follow, well, that has a special name. We call it programming. And that's all programming really is. It's just the language we use to tell a computer exactly what we want it to do. All right, so we figured out that computers need instructions to do anything at all. But that brings up a really interesting question, doesn't it? What's the difference between the instructions themselves and the actual physical machine that's running them? Well, that's exactly what we're going to get into next time. We're going to build on this idea and explore the difference between hardware, the physical parts of a computer you can actually touch, and software, which is all that programming that brings the machine to life. So, I'm going to leave you with this one thought. Now that you know a computer is basically just this incredibly powerful machine that's waiting for your instructions, what would you tell it to do? What problem out there would you want to solve? The possibilities? Well, they're literally endless. Thanks for tuning in.